Okay, today we're going to cover 10.3 and we're only going to talk about polygons and perimeters, not tessellations. So, as we go through, we're going to make sure you know how to, or refresh your memory on naming certain polygons according to their sides, recognizing their characteristics, and then solving problems involving perimeters and the sum of the measures of a polygon's angles. So, first, any closed shape in the plane formed by three or more line segments that intersect only at their endpoints is called a polygon. Must be closed and must be made up of line segments. Now, if all the sides are the same and all the angles are the same, we call it a regular polygon. And of course, the sum of the lengths of the sides is what we define as the perimeter of a polygon. All right, let's go review the polygons. These are all regular polygons, so if we have the first one, you should all know as, I'm sure you all know that the first one, any polygon with three sides, is called a triangle. So we can have a regular triangle, although that's not what it looks like. The next one we have, if it's four sides, it's called a quadrilateral. Now, if it's a regular, okay, remember that means that it's all four sides are equal and all sides are equal. That's where we get into the square. A five-sided figure is called a pentagon, like that building in Washington, D.C. A six-sided figure is called a hexagon. Seven-sided is called heptagon or septagon. Either one is acceptable. Eight-sided figure is called an octagon. Okay, next we're going to talk about the different types of quadrilaterals. Okay, the first one, hopefully you can recognize from the picture, is a parallelogram. Now, the characteristics you need to remember about a parallelogram is that both pairs of opposite sides are parallel and have the same measure. Opposite angles also have the same measure. Okay, the next, if our tick marks show that all four sides are equal, then it's called a rhombus. All sides have the same length. Okay, if we have not necessarily four equal sides, but four equal angles, then we have a rectangle. Okay, four right angles forms a rectangle. And next, if we have four right angles and four congruent sides, you know that it's a square. All right, it's a rectangle with all sides having the same length. And of course, each angle measures 90 degrees. Okay, and as we just mentioned, it's a regular quadrilateral. And a quadrilateral with exactly one pair of parallel sides, which means one and only one, is called a trapezoid. So let's look at the type of problems. You're going to need to know those characteristics, and then we're going to do some problems with perimeter and these polygons and their angles. So fencing costs $5.25 a foot. Find the cost to enclose the field with fencing. So here is my field, shows you the dimensions. We need to find out how much it's going to cost to get fencing. So first, we need to find the perimeter of the rectangle in yards, because that's what it's given me. So your formula for perimeter, you remember, is 2 times the length plus 2 times the width. Does it matter which one's the length and which one's the width? It does not. So 2 times 42 yards plus 2 times 28 yards is going to give us a total of 140 yards. So that's our perimeter. Next, we need to go take that and convert it to feet. So I had 140 yards. I'm going to write that over 1 because this is that process, you call it factor label method, dimensional analysis, unit conversions. However you do, it's an important thing to know how to do. So to go from yards to feet, remember I need yards on the bottom to cancel. So I'm going to multiply it by that unit conversion of 3 feet equal to 1 yard. Okay, that makes my yards cancel, which leaves me 140 times 3 feet, or a total of 420 feet. So now I got to go find out the cost. So my cost per foot is $5.25. So I'm going to start off with 420 over 1. again, $5.25 per foot, and I'm doing that so that my feet cancel, and that leaves me with 420 times 525, which equals 2205, $2,205. All right, let's go do one. We have a rectangular field that has a length of 50 yards and a width of 30. Okay, again, pause if you want to try it on your own. So the first thing that we needed to do was to find the perimeter, which was 2 times the length plus 2 times the width. My length was 50. My width was or is 30. So 2 times 50 plus 2 times 30 is a total of 160, and we're in yards. So part B says I got to convert those yards to feet. So I took my 160 yards, put it over 1, times how many feet in a yard? 3 feet, 1 yard. My yards cancel, leaving me with a total of 480 feet. Not done yet. Okay, so we go to step C, which means I got to take the 480 feet over 1 times, what's my cost per foot? Right here, 650 per foot. My feet cancel, so 480 times $6.50 gives me a total of $3,120. Okay, so moving right along, we have angles. Remember, the sum of the measures of an angle of the angles of a polygon within sides is n minus 2 times 180. And just to give you a visual on that, however many sides you have, 1, 2, 3, 4, think about how many triangles can be formed. 4 sides gives me 2 triangles. 5 sides gives me 3 triangles. 6 sides gives me 4 triangles. So it's always the number of triangles that you get times 180. So they ask us to find the sum of the measures of the angles of an octagon. So the hardest thing you got to do is how many sides are in an octagon. So you know that, hopefully, that using the formula, an octagon has 8 sides. So we're going to take our formula of n minus 2 times 180, put in 8 for n, and we'll have 6 times 180, which is a total of 1080 or 1080 degrees. So let's go do one ourselves. Find the sum of the measures of the angles of a 12-sided polygon. So we have, again, helpful to write that formula down. That's how it gets in your brain. The more you write it, the easier it is for you to remember it. So n is 12 minus 2 times 180, and we have 10 times 180, which is 1800. So the sum of the measures, and keep in mind, this one's asking for the sum, okay? The next question is asking for the measure of one angle. So I'm going to take 1800 and divide it by how many angles do I have? 12, and that's going to give me each angle measuring 150 degrees. Okay, the last thing I want to do is to go back and refresh your mind. We got application problems like that, but I wanted to redo 2 from our previous lesson. So here is an example. A person who is 5 feet tall is standing 80 feet from the base of a tree, casts an 86-foot shadow. The person's shadow is 6 feet in length. What is the tree's height? Round your answer to the nearest tenth of a foot. Okay, so it tells us up here that we want to use similar triangles to solve it. So remember when we did that, we always talked about you want to write in words what you're comparing or what your ratio is. So if you choose small to big, big to small, does not matter. Regardless, when you set up your proportion, this all parts of the small triangle need to be on top. So that would make a 5 and a 6. And then you go to the big one and say, what corresponds to the 5? Well, this is my 5. And this is actually what I'm looking for. So that's going to be my T. And then this will be what corresponds to the 6. And don't get fooled, it's not 80, but it's actually the whole thing, as they tell us up here. It's an 86-foot shadow. So we have to have the whole thing. So again, we cross multiply. 430 equals 6t. Divide both sides by 6. And t equals 71.6. Repeating, okay? Which means that it's 71.666. And if I have to round to the nearest tenth of a foot, that's going to give me 71.7 feet. Okay, last problem. Application involving the Pythagorean theorem. A baseball diamond is actually a square with 90-foot sides. What is the distance from home plate to second base? So in this one, again, they want us to use a calculator, and we're going to the nearest tenth. All right, but in case you can't see, this is what we have as the right angle. Not so hot. All right, each side is 90, they told me. Okay, and this is x, that's what I'm looking for. So you remember your Pythagorean theorem that this squared plus that squared equals the hypotenuse squared. So that gives me 90 squared plus 90 squared equals x squared. And so, excuse me, x squared equals, add those two up. Now, I'm going to write this because some calculators will give it to you like this, so I want you to see it. It also might refresh your memory from geometry when you have special right triangles. If these are the same, then the hypotenuse is 90 square roots of 2. However, they want it to the nearest tenth, so you need to figure out what that decimal number is. And when you do, it is 127.279. It keeps going, but we're supposed to round to the nearest tenth, so we have 127.3 feet. And that's all we have for 10.3. Please come ready to work and with any questions that you might have. Have a great day.